Yeah, so good morning. So it is once again another fine morning with step down over here. I want to welcome you to my YouTube channel, and we're going to learn something in chemistry. Yeah, but before that, I just want to remind you that don't forget to press on the bell so you don't miss the latest updates with the latest post by teacher Dan Got A. Yeah, or you can call me Dan. Now, today in chemistry, we're going to learn on the substrand, the periodic table. Yeah, in the previous class we learned on the atom, and even in the earlier one we learned on the introduction to organic chemistry. Yeah, so all these are found in the strand in organic chemistry. So in inorganic chemistry we learned two of the strands, and today we are going to tackle the third one, which is the periodic table. And I believe that that's watching over there are going to get to learn a lot and have fun with done. Yeah, so welcome. Now let's dive very fast. Save on time with effervescence. I will remind you that. Yeah, so today in chemistry, okay. Yeah, so we are going to learn on the substrand, the periodic table. Now, the periodic table, I believe this is something that you've heard, even maybe in your earlier classes or maybe from friends, discussions, you've heard of the periodic table. Yeah, and we're going to clarify on that today. What is the periodic table? So periodic table, it is simply a systematic arrangement of elements ordered by their atomic number. Okay, yeah, it is a systematic arrangement of elements ordered by their atomic number. Yeah, so that is what we're going to learn today. And what are we going to learn in this substance? We're going to learn of the properties, okay, of the elements, okay. At the same time, we're going to learn on the electron configuration of the elements, okay. We're going to learn on the properties and even the electron configuration of elements, okay. Yeah, so this is what we're going to tackle under this substrand, the periodic table. Okay, we're going to learn of the properties of various elements. At the same time, we're also going to tackle on the electron configuration of the elements. Okay, yeah. So first thing that I would like us to do first is to draw the structure, or just to draw the first 20 elements of the periodic table, and this we will analyze it, and it will enable us to understand a lot of things in the periodic table. Okay, yeah, I believe you know the first 20 elements of the periodic table. So you have the group side and you also have the period side. Okay, the groups, there are a total of 8 groups. Okay, so we have group 1, okay, then group 2, then group 3, group 4, group 5, group 6, group 7, and group 8. Okay, yeah, and the periods that we'll be having, okay, period 1, period 2, period 3, period 4. Okay, yeah, so let's just draw period 1, period 2, have it there, and period 3, we're going to have it there. Yeah, so they're that way, they're now there. So now those are the first 20 elements of the periodic table. So once you've known the first 20 elements of the periodic table, okay, now we're going to go to the next part. Okay, yeah, so when we say that it is a systematic arrangement of elements, okay, of chemical elements in relation to their atomic number, I believe that now you can see why the atomic number is very crucial, why it plays a very huge role in atoms. Okay, yeah, because you get that it is the one that has also been used in putting in the positioning of the elements. Each element, you can know it by the atomic number. Okay, yeah, so that is the first 20 elements of the periodic table. And I want to check on the position of the elements, the periodic table, which I have told you that the easiest way of locating them is through knowing their atomic number. Okay, just know the atomic number of the first 20 elements of the periodic table, and it will be very easy for you. Okay, yeah, and now in positioning of elements in the periodic table, they are positioned in terms of either a group or even a period. Okay, a group or even a period. And I told you that the groups that we're having, the first 8 groups of the periodic table, those are the groups that we're having. And at the same time, we're also having periods in the periodic table. So you can be asked that which element is found in group 4, okay, in group 4 and the period 3 of the periodic table. So group 4, where's group 4? Group 4 is in, okay, and period 3. So that element will be silicon, okay, group 4, period 3. So through the groups and the periods, you can locate an element in the periodic table. Okay, yeah. So it's just that simple. So the group at the vertical, okay, the vertical on the vertical column, okay, the vertical column represents the group. Then on the horizontal rows, that's where we're having the what? The periods. Okay, we're having the periods. Now, in understanding the group and the periods, the groups and periods, something crucial that you should know about it is that elements that are found in the same group, they have the same number of electrons in the outermost energy level. Okay, yeah. So like the elements in group 1 of the periodic table, they are all having an electron which is one electron in their outermost energy level. Okay, yeah. So like the hydrogen, the lithium, the sodium, and the potassium, all of them are having one electron in their outermost energy level. Even when you check on these other ones, like in the maybe in the group 7, you have chlorine. Okay, all these they are having 7 electrons in their outermost energy level. So through groups, we can know that elements that are found in the same group, they're having the same number of electrons in the outermost energy level. Okay, yeah. How about periods? Periods, they play a role in that. Elements that are found in the same period, they have the same number of energy levels. Okay, yeah. So like the elements in group in period one, this one, they're having one energy level. Okay, one energy level each. When you check on the second period, lithium, beryllium, boron, carbon, nitrogen, oxygen, chlorine, neon, all these they are in the same period, and now they are having the same number of energy level. It will be two energy levels. Okay. Period three, each element will be having a total of 3 energy levels. Okay. When you go to period 4, each element will be having a total of 4 energy levels. Okay. Yeah. So we get that groups and periods, they play a crucial role in positioning of the element. So through that you can locate an element in the periodic table. Okay. Yeah, so that is just on location of the elements in the periodic table. But maybe just to check out on some examples on the element. Okay. Yeah. So for example, let's check on sodium. Okay. Sodium and potassium. Okay, let's check on sodium. Sodium having an atomic number of 11. Okay, 11. So what is the configuration? It will be 2, 8, 1. Okay, when you put it in terms of orbitals, it will be 1s2. Okay, 1s2. Then we have 2s2. 2p6. Then you have 3s1. Okay, yeah, that is for sodium. Okay, so this sodium is having 2 electrons in the first energy level, 8 electrons in the second energy level, and 1 electron in its outermost energy level. Okay, let's check on potassium. Okay, potassium is having 19, that is the atomic number. So it will be having 2, 8, 8, 1. Okay, in terms of orbitals, it will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Okay. Now when you check this one thing, you get that the potassium is having 1 electron in its outermost energy level. For sodium was 1 electron in outermost energy level. So you get that the elements that are in group 1, they are having the same number of electrons in their outermost energy level. Okay. You also check on the elements maybe like in group 7 on the periodic table. That they are having the chlorine. Okay. Chlorine that's having an atomic number of 9. What is the configuration? 2, 7. Okay, then we have chlorine that is having 17. The atomic number is having 2, 8, 7. Okay, you see there are 7 electrons in the outermost energy level, also 7 electrons in the outermost energy level. Let's put that just to jumpstart your memory on the orbitals. So the chlorine will be 1s2, then 2s2, 2p5. Okay. Then this one will be 1s2, 2s2, 2 P6, then 3s2, 3p5. Okay, you can see that there are the same number of electrons in the outermost energy level. Okay, and then we'll just check on the now the periods. On the periods are having sodium and chlorine on the same period. Okay, how many energy levels are they having? So for sodium, we get that they're all having 1, 2, 3 energy levels. Okay, 3 energy levels. Okay, how about chlorine? Chlorine is having also 3 energy levels. So I believe that you can differentiate that. You can see how it is coming. It's just that simple. Okay, yeah. So once you've known of the groups and even the periods, the next thing that you should know is now the chemical formulas. Okay, the chemical formulas. So these elements in the periodic table, they belong to a certain chemical formula. Okay, and the chemical formula that you will know at this level, you'll be having the first elements in the first group of the periodic table, the elements in the second group of the periodic table, the elements in the seventh group of the periodic table, and the elements in the eighth group of the periodic table. Okay, so the first one are in the group 1, that are known as alkali metals. Okay, then we have group 2, that are known as the alkaline earth metals. Okay, then we have group 7, that are known as the halogens. Okay, then we have the group 8, that are known as the noble gas. Okay, yeah, so those ones are the groups, are the chemical families of elements in the periodic table. So elements in group 1 are the alkali metals, group 2 are the alkaline earth metals, group 7 are the halogens, and group 8 are the noble gas. Okay, yeah, so mark that. Once you've known that, the next thing that you can tackle now next is the ion formation of elements in the periodic table. Ion formation of elements in the periodic table. Now, when we're speaking about ion formation of elements in the periodic table, we are referring to how elements gain their stability, okay, in the periodic table. And in order for this to take place, they can take place either by them losing electrons, or even gaining electrons, or even sharing of electrons, okay. Gaining, losing, or sharing of electrons. That is how they obtain their stability. Okay. Yeah. Now, this process, it leads to the formation of now the ions. Okay. This is the formation of ions. So we want to deal with ion formation of elements in the periodic table. Now, some elements, to gain their stability, they will lose electrons. Okay. Some will gain electrons, okay, it's either by losing or gaining of electrons. But this will result in the formation of either a positive ion, okay, a positive ion, or a negative type ion. Okay, now a positive ion will be known as the cation, while the negative ion is known as an ion. Okay. Yeah, so the positively charged ion is known as the cation, while the negatively charged ion is known as the anion. Okay, yeah. And now, for them to gain this stability, you'll get that some elements will end up having only 2 electrons in the outermost energy level in that their state. Okay, yeah. While others will be having 8 electrons in the outermost energy level in that stable state. Okay, and really let's start talking about something known as a duplet and an octet. Okay, a duplet and an octet. What is a duplet? A duplet, these are atoms that for them, when they are in stability form, they are having only 2 electrons in the outermost energy level. While octet, they'll be having 8 electrons in the outermost energy level. Okay. Yeah. And you will realize that those that are in duplet form, they will be having only 1 energy level. Okay. While the one for octet, they can even have more. Okay. Yeah, it has to be more than 1. Okay. Yeah. And now for you to understand it easily, I will want us to draw a structure of some of the elements. Okay. so that we can understand the duplet, the octet, the cation, and even the anion, okay, in an easy, simpler way. So let me draw the structure of lithium, okay, and just for you to know that you see these elements in the first three groups, okay, elements in the first three groups, when they become stable, they end up being cations, okay. Okay, so cations, they are the metals in the group 1 to group 3. They are the ones that will form the cations. While the anions, which are the negatively charged ions, will be all the way from group 5 to group 7. Okay, yeah, the negative ions. Okay, yeah. Now, let's check on lithium. So lithium, it is this way. Okay, the atomic number of lithium is 3. The configuration will be 2, 1. Okay, yeah, 2, 1. So when it becomes stable, it will be easier for lithium to become stable by losing an electron, which is 1 on the atom's energy level, okay, than for it to gain 7 more electrons not to become stable. Okay, so when it becomes stable, it will end up just having 1 energy level, it will be having 2 electrons. And if it ends up that way, it becomes a what? A duplet. Okay, a duplet. Now, let's just do the structure, work on the configuration. Okay, so lithium is having, we have this there, let's say that is the nucleus. Okay, then now the first energy level here, which is having 2 electrons. Okay, then now the second energy level, which is having just 1 electron. Okay, so for it to become stable, it will lose 1 electron. Okay, so we end up with, that's the nucleus. Then now we have this. Okay, so how has it formed? Lithium, okay, it has lost 1 electron to give us this. Okay, it has lost 1 electron, okay, that to become now the cation, positively charged. It has lost 1 electron, okay, and now since it is having just 2 electrons in the outermost energy level in its stability and 1 energy level, okay, it is known as a duplet. This is what is known as the duplet, okay, the duplet. So remember that the first group, second group, and the third group of elements, when they become ions, they end up in positive ion, okay, which is known as the cation, okay, yeah. And that one is for lithium. Let us try to draw the one for magnesium, okay, magnesium, which is having 12 as the atomic number. So magnesium will be this way, okay. So magnesium, this will be the configuration 2, 8, 2, okay. Yeah, so how will it form? So it will be easy for it to lose the 2 electrons in the outermost energy level to become stable. Okay. So we said that is the nucleus, magnesium, okay, at the first energy level, okay, it's having 2. At the second energy level, it's having 8. Okay, then the third energy level, it's having 2 electrons. Okay, so it will lose the 2 electrons, okay, and end up this way. So we have the nucleus in the first energy level, in the second energy level. Okay, it has lost 2 electrons. Okay, it has lost 2 electrons. So magnesium, when it becomes an ion, comes this way. You see that? Now that is what has taken a second place. So magnesium has lost 2 electrons for it to become now the ion. Okay, it is now the cation. It has lost 2 electrons. So I believe that you've understood how the cations are. Okay, and this magnesium is having 2 electrons in its outermost energy level in becoming stable. This is known as an octet. Okay, an octet. Yeah, and I believe that you've understood that well and clear. Now, that one is on the formation of the cations. Okay, now let's check on now the formation of the anions. Okay, yeah, let's also check on the formation of the anions very fast. The anions now are the ones that become stable by they will gain electron in the outermost energy level, okay, to become stable. Allow me to use chlorine as an example. Okay, so chlorine, which is having 17 as the atomic number. Okay, the energy levels will be the configuration 2, 8, 7. Okay, yeah. Now this one is the configuration. Okay, So it is having a total of 7 electrons in its outermost energy level. It will be much easier for chlorine to become stable by gaining an electron to its outermost energy level than losing the entire 7 electrons in its outermost energy level. Okay, so this one will become stable by gaining an electron to itself. Okay, and when it does that, it will end up being an anion. Okay, so just to draw the structure of how it looks like. So chlorine will be this way. Okay, so there we have the nucleus, chlorine. Then you have the first energy level. Okay, so we'll be having 2. In the second energy level, 2, 3, 4, 5, 6, 7, 8. Then the last energy level that way. Okay, it will be having 7, 7. Okay, yeah. So that is chlorine. So for chlorine to become stable, okay, it will gain an electron. Okay, and now this is how it will result. So for a stable chlorine, it will be this way: 2, 8, 8. Okay, yeah, and that one will be the first energy. That's the nuclear. Okay, then the first energy level, the second energy level, then now the last energy level there. Okay. So that one is chlorine. So what has happened here? So chlorine, okay, has gained an electron, okay, to become now the chlorine ion. Chlorine has gained an electron to become now the chlorine ion. Okay, yeah. So it has become stable now, having 8 electrons in its outermost energy level. Hence, it is an octet. Okay, yeah. So I believe you've seen how that is coming, of how the electrons gain their stability. It is either by gaining an electron or even by losing an electron. Okay, I believe that you understood how that is being done, right? Yeah. So since you've already known that, let's go to the next part. So by now we'll be discussing on the valencies, and then on the atomic, not atomic but rather oxidation number. Okay, yeah, oxidation number. Now, just from the observation of these elements, you can get to know of their valencies and even the oxidation number. First, just get to know what is the valency. Valency, this is the number of electrons that is required by an atom to gain its stability. Okay, it is the number of electrons that is required by an atom to gain its stability. So for example here, when you use chlorine just required 1 electron to its outermost energy level to gain its stability. So what is the valency of chlorine? It is 1. Okay, it was deficit of 1 electron to gain its stability. And now that it's 1 electron that it has obtained to gain its stability, so it will be, the charge will be minus. Okay, for chlorine it will be minus. So the oxidation number for chlorine will be what? Minus 1. Okay. That is for the chlorine. So this was the valency and oxidation number. They're not that far from each other. The valency is just the number of electrons that is required by an atom to gain its stability. Okay. While oxidation number is the number of electrons that has been gained or lost by an atom to gain its stability. So for chlorine, it did what? It gained 1 electron to gain its stability, which now the oxidation number was minus 1. Okay. How about magnesium? Magnesium, for it to gain its stability, it did what? It lost 2 electrons. Okay, it lost 2 electrons. Once it lost the 2 electrons, the oxidation number for magnesium was plus 2. Okay, that is the oxidation number for magnesium. Okay, yeah. So oxidation and valencies, it's just that simple to understand. There is not much relate on it. Yeah. So that is on it. And now the next thing that is also going to know is now that the radical. Okay, there is this thing that's known as the radical. Believe that you've heard of it. Sometimes it can seem scary to some people, but it's just easy. Okay, yeah, just get to know it. So radical. What is a radical? Okay, radicals. We say that a radical is a group of atoms. Okay, with a net charge. A group of atoms with a net charge and react as a unit in a reaction. Okay, so first we say that it is a group of atoms. Okay, and then they have a net charge. Group of atoms with a net charge. And when they take part in a reaction, they react as a single unit, in that they react as as 1. Okay, as 1. So just some examples of these radicals that we know. For example, we can have nitrite, okay, nitrite, we have nitrate, we have carbonate, we have hydrogen carbonate, okay, we have hydrogen sulfate, okay. Those are examples of radicals, okay. So this one is nitrite, this is the nitrate, this one is the carbonate. Okay, just from the observation you see that it is having a net charge, okay, which is over here, okay, group of atoms, it's made up of nitrogen and 2 atoms of oxygen, okay, so it's group of atoms, okay, and so it's having a net charge. For nitrite, nitrate the same, for carbonate the same, carbon, oxygen, oxygen are 3, and then you have the net charge there which is 2. So they are a group of atoms with a net charge, and when they take part in a reaction, they take part as a single unit, okay. Yeah, as a single unit. So those are just examples of them. That is hydrogen carbonate. That's just another example of the radicals. So radicals, they are simply a group of atoms with a net charge, and they act as a single unit during a chemical reaction. Okay. Yeah. So that is just on that. So next, let's check also on the chemical formula. Chemical formula. So I believe that you understood quite a lot on that. Okay, let's check on the chemical formula. Chemical formula. Chemical formula. Chemical formula. Now, chemical formula. What is the chemical formula? Chemical formula is a representation of a chemical substance using chemical symbols. Okay, representation of a chemical substance using chemical symbols. So this is the representation of chemical substance using symbol. And not just symbol, a chemical symbol. Okay, representation of a chemical substance using chemical symbol. And something that is so good about chemical formula is that it enables us to identify the constituents that make up the chemical substance, and at the same time enables us to identify the proportions, the proportionality of the substances. Okay, yeah, it enables us to know the constituents and proportionality of substances. That is chemical formula. So it plays a very good role for us in knowing the constituents and the proportionality. Let me just give out some examples that can enable us to identify the constituents and even the proportionality of the substances in a chemical formula. For example, let's say water. Okay, water. What is the chemical formula for water? It is H2O. Okay, so from this formula H2O, we get that we're having number 1, the hydrogen. Then number 2, we're having oxygen. And from this, you get that the hydrogen, they are in proportion of 2. We have 2 hydrogen atoms. Okay, so hydrogen have been put in 2 proportions, where oxygen is just 1. So from that, we can get that we're having the constituents, which is hydrogen and oxygen. Okay, and now the proportionality, you get that hydrogen, we have the 2 atoms of hydrogen and 1 atom of oxygen in the formation of water. Okay, yeah, so that is how we identify the what? The constituents and even the proportions of substance in using a chemical formula. Okay, let me just check also on another example. Let's have aluminum sulfate. Okay, aluminum sulfate. So aluminum sulfate, Al. Okay, 2, so 4, 3. Okay. Now from this, we get that we're having aluminum, 2 aluminum. Okay, and now the sulfate, we're having 3. Sulfate I will put in 3, proportion of 3. And now the sulfate itself is having sulfur and oxygen. And now, just to just start your memory, remember that now this over here is a what? It was a radical. Okay, a radical. And remember that when they take part in a reaction, they take part as a single unit. Okay, as a single unit. Yeah. So aluminum, we are having aluminum, 2 aluminum. The sulfate, we are having them 3. Okay. So we are able to get the constituent and even the proportionality of the substances that have been used in its formation of the substance. Okay, and I believe that really understood that is coming through. And now in this next part, I just want to give you like an easy way. Okay, an easy way of getting the chemical formula, in that there are steps that have been put for you in writing a chemical formula. They are easy and they can lead you into writing the chemical formula. Okay. Yeah, so and for that, just allow me to erase this over here. Now, when you're writing a chemical formula, what you should get to know is that number one, know the correct chemical symbol of each element, or even just know the symbol. For example, I want us to write let's write the chemical formula for sodium oxide. Okay, let's write the chemical formula for sodium oxide. We are going to follow these steps when writing the chemical formula. Okay, so number one, you get that? Know the correct chemical symbol. Okay, yeah, we will write it down. So write, so sodium, that is the symbol. We have sodium, the oxygen. Okay, that was number one. Number two, write the valency of each element. Okay, write the valency underneath. Okay, so write, okay, for sodium it is having valency of 1, for oxygen it is 2. Okay, then number three, swap the valency. I will swap them. This will go this way, this will go this way. Okay, after swapping, then so put them together, put it together. So it will be Na2 1. Okay, then number 5, so simplify by exercise. So like for this one, it will just be Na2O, sodium oxide. So we have written that chemical formula for sodium oxide. And I believe that just from the steps itself, it's very easy simplified, and you can work it out in an easy way. Okay, easy way of writing the chemical formula. Okay. Yeah, maybe just to give also another example that now we'll be having that we can simplify. Okay, another example that we can simplify. So when you're trying to write the chemical formula for, let's say you have been given magnesium sulfide. Okay, magnesium sulfide. Okay, so magnesium sulfide. So first write the chemical symbol. Magnesium is Mg, for sulfur which is S. Okay, magnesium is having valency of 2, sulfur 2. Okay, that's the 2. The third one, swap the valencies. Then we put it together. So we have Mg2S2. Then simplify when necessary. Now we are having Mgs, and you will have obtained the magnesium sulfide. Just that easy. Okay. Yeah. And now the next one, let's try now to write the one for carbon dioxide. Yeah, the one for carbon dioxide. Okay. Yeah. So first write the chemical symbol. Chemical symbol, we have carbon is C, oxygen is O. Okay. The valency for carbon is, so valency for oxygen is 2. Okay. Then now you swap. Then you get C2O4. You simplify, you get CO2. Just like that, you'll have obtained your chemical symbol. You'll have obtained your chemical symbol for carbon dioxide. Okay? Yeah. So, when you're writing the chemical formula, just follow on these steps. You write the correct chemical symbol, then you write the valency of each element below the symbol. Okay? Then you swap the valencies, then you put it together, and finally you simplify to end up with your answer. Okay, yeah, so it is just that easy. And now, in this next part, I want us now to write on the chemical equations. Okay, the chemical equations. I'm going to introduce you to now the chemical equations. Chemical equations. What is a chemical equation? A chemical equation, it is simply the symbolic representation of a chemical reaction. Okay, the symbolic representation of a chemical reaction in the form of symbols. A representation of chemical reaction in the form of symbols. Now you use the symbols. Okay. Yeah. A representation of chemical reaction in the form of chemical symbols. Okay. And now when you're writing the chemical equation, we will always be having the reactants and the products. Okay. We will always be having the reactants and the products. Let me just write an example of a chemical reaction. Okay. The chemical equation. Let's say we are having magnesium reacting with oxygen to give us magnesium oxide. Okay. Now from this we get the reacting magnesium reacting with oxygen to give us magnesium oxide. Okay. So here we get that magnesium and the oxygen. These ones are the reactants. Okay. And this that we have here is the product. So on your left, you are having the reactants, on your right, you are having the product. Okay. And when you're writing the chemical equation, you should always ensure that it is balanced. Okay. Yeah, balancing of chemical equations. Now, for example, here, you're having magnesium is one atom on the reactant side. On the product side, it's also one. How about oxygen? Oxygen on the reactant side, we are having two atoms of oxygen, but on the product side, we are having one. So this is enough to tell you that it's not balanced, because on the reactant, we are having two atoms of oxygen, but on the product side, we are having just one product of one atom of oxygen. So we have to balance it. Okay. So how do you balance it? Check on magnesium. 1, 1. That's good. Okay. How about oxygen? 2, 1. On this side it is 1, but this side it is 2. How will you make it to rebalance? You'll have to add 2 on this side. You have to make the oxygen on this other side to be 2. Okay. So when you make the oxygen 2, it will now be 2 magnesium, 2 oxygen. Oxygen here, but now here we're having 1 magnesium. So we have to balance this one too, magnesium and magnesium. So this side, if you put, we're having 2 magnesium, to make this one 2, we put a 2 here. Okay. So we have 2 magnesium, 2 magnesium, 2 oxygen, 2 oxygen. And that way it has become now balanced. Okay. Balanced. So balancing of chemical equations, it is very important. Okay. Yeah. And ahead you will also get to go deeper in the balancing of chemical equations. We'll be writing even more advanced chemical equations and balancing them. Okay. Yeah. So prepare for that. But for now, we just talk it about. Just know that when we are writing the chemical equations, there is the reactants and there is the product side. Okay. And now the samples of the reactants must be equal to the samples on the product. Okay. Yeah. So just get marked that, and that is where now the balancing comes through. Okay. Yeah. So I believe that you really learned a lot in this class, and Teacher Dan is going to stop at that. And you've just depleted on the substance, the periodic table. We'll tackle our next substance in our next class. Okay. So I believe that you learned something and you really enjoyed this class. So see you in our next class, and please don't miss. Just press on the button so you don't miss on any update by Teacher Dan Got A. So see you there. Bye.